Alrighty, now let's go. Okay, so other vector operations now. In addition to vector push, vector provides only a few other operations, most of which are similar to corresponding operations of string. Okay, this is the most important ones. We access the element of vector the same way that we access the characters in a string through their position in the vector. Right. For example, we can use the range for to process all the elements in a vector. Okay, we are taking the reference, then we are multiplying, squaring, right. Okay. And we are printing it. In the first two, we define a control variable I as a reference so that we can use I to assign new values to the elements in V. We let auto deduce the type of I, right. This loop uses a new form of the compound operator, right. The result, the multiple, similarly accept that it multiplies left hand and right hand operands, storing the result in the left hand one. The second for range prints each element. The empty and size members behave as do the corresponding string members. Empty returns the bools with the vector, where the size returns the number of elements in the vector. This size returns size type defined by the corresponding vector. Okay. To use size type, we must name the type in which it is defined. A vector type always includes these elements. Okay, this is okay. However, this is error. Okay, so vector int size type, okay, and vector size type is not. Okay, the equality and relational operators have the same behavior as the corresponding strings operations. Two vectors are equal if they have the same number of elements and if the corresponding elements have all the same values. The relational operator apply a dictionary ordering. Okay. Right. The relation operator applies a dictionary ordering if the vectors have different sizes but the elements that are in common are equal. Okay. Then the vector with fewer elements is less than the other. If the elements have differing values, then the relationship between the vectors is determined by the relationship between the first elements that differ. Okay. Okay. Then we can compare two vectors only if we can compare the element in those vectors. Okay. Some class types such as string define the meaning of equality and relational operators. Others such as class item do not. The only okay, so this is important. Okay. The only operations sales item support are those listed here. Okay. Those operations did not include the equality or relational operators. As a result, we cannot compare size object. Okay, so we have empty, size, pushback, reference, then equality, check the equality, places, checks the equality, inequality, less than, and relational operators. Places element copy, comma separated list, replaces element view the copy of element. Yeah, okay. Computing a vector index. We can fetch a given element using the subscript operator. As with string, subscripts for vector start at 0. The type of a subscript is the corresponding size type, and assuming the vector is non-const, we can write to the element returned by the subscript operator. Okay. Right. In addition, as we did in 3.23, we can compute the index and directly fetch the element at that position. Okay, as an example, let's assume that we have a collection of grades that range from 0 to 100. We'd like to count how many grades fall into various clusters of 10. Okay. Between 0 and 100, there are 101 possible grades. These grades can be represented by 11 clusters, 10 clusters of 10 grades. Okay. So we have 10 clusters of 10 grades, each plus 1 cluster for the perfect score of 100. Okay, so 0 to 10. Okay, 1. Okay. Alright. The first cluster will count 0 through 9. The second and so on. The final cluster counts how many scores of 100 were achieved. Okay. Clustering the grades this way is the input and the output should be okay, which indicates that the number of grades below 30, one grade in the 30s. There were no grade below 30, one grade in the 30s, one in the 40s, one in the 50s, two in 60s, three in 70, 100. Okay. So we'll use a vector of 11 elements to hold the counters for each clusters, right? Okay. Then we can determine the cluster index. We can determine the cluster index for a given grade by dividing the grade by 10. Okay. When we divide two integers, we get an integer in which the fractional part is truncated. For example, 42 divided by 10 is 4. Okay, so this will be in the range of what is 30 to 39. 30 to 39. No, sorry, 40 to 49. Okay, 60 to 69. 10 by 10 is 10. Once we've computed the cluster index, we can use it to subscript our vector and fetch the counter we want to increment. Okay. Count the number of grades by cluster 0 to 9, 10 to 19. Okay. So vector 11 buckets, all initially 0. We have unsigned grade. We take in grade, reads the grade. If grade is less than equals 100, equals score plus plus grade by 10. Okay. And we start by defining a vector to hold the cluster counts. In this case, we do want each element to have the same value, so we allocate all 11 elements, each of which is initialized to 0. The while command reads the grades inside the loop. We check that the grade we read has valid value. It's less than, grade is less than equal to 0. Assuming that the grade is valid, we increment the appropriate counter for grade. Okay. A statement that does the increment is a good example of the kind of terse code, right? Okay, so we fetch, increment the counter of the score, we fetch the value at there, right? It is equivalent to this, then increment the value. Okay, we compute the bucket index by dividing grade by 10 and use the result of the division to index scores. Subscripting scores fetches the appropriate counter for this grade. We increment the value of that element to indicate the occurrence of a score in the given range. As we have seen, when we use a subscript, we should think about how we know that indices are in range. In this program, we verify that the input is a valid grade in the range between 0 to 100. Thus, we know that the indices we can compute are between 0 to 10. These indices are between 0 and scores size minus 1. Okay. Subscripting does not add elements. Okay. Programmers new to C++ sometimes think that subscripting a vector adds elements. It does not. The following code intends to add 10 elements to vec. Okay. However, it is an error. IVec is an empty vector. There are no elements to subscript. As we have seen, the right way to write this loop is to use pushback. Okay. The subscript operator on vector and string fetches an existing. It does not add an element. Okay. And with caution, subscript only elements that are known to exist. Okay. It is crucially important to understand that we may use the subscript operator to fetch only elements that actually exist. For example, there are no elements here and there are no elements here, because it is just a 10 vector with 10 elements and we don't have the 11th element. Okay. We get the element 0 to 9. It is an error to subscript an element that doesn't exist, but it is an error that the compiler is unlikely to detect. Instead, the value we get at the runtime is undefined. Okay. Attempting to subscript elements that do not exist is unfortunately an extremely common and pernicious programming error. So-called buffer overflow errors are the result of subscripting elements that don't exist. Such bugs are the most common cause of security problems in PC and other applications. Okay. Yeah, a good way to ensure that subscripts are in range is to avoid subscripting altogether by using a range form. Right. Okay. So we have exercise 333. Write a program to print the size and contents of the vector from exercise 313. Check whether your answers to that exercise were correct. If not, restudy 3.3.1 until you understand why you were wrong. Okay, so I have an exercise 3.3.3 and PowerShell, right? Okay. So create a new file which is 3.16.cpp 3.16.cpp dash include iostream dash include vector. Okay, delete this. Alright, so we have this. Okay, write a program to print the size and contents of vector from exercise 3.13. Okay, where is exercise 3.13? 3.13. How many elements are there in each? Okay, so we can do that, right? So using std cout, std cin, std endl, and std vector. There we go. Okay, let's declare slash define our vectors. So we have vector v1, v2. Okay. So vector int v1. Okay, size is 0. Then we have vector. We have size 10 and v2 10. Size is 10. Okay, then we have vector v3 and v3 10 comma 42, right? 10 comma 42. Okay, size is 10 and all elements are initialized to size is 10. Okay, then we go vector int v4 10 for curly brackets 10, size is 1, and we have vector int 10 and 42. v5 we have 10 and 42. So size is 2, right? And we have vector of string, so I should include string. std string. Okay, so we have string v6. Okay, so since 10 is not a valid value for a string, it will uses the parentheses instead. So size is 10, right? And vector 10 of vector string v7 Same logic. Size is 10. All initialized to high. Okay, so let's print v1 dot size. Go v1 bit shifting 3 4 5 6 7. Okay, v2 v3 v4 v5 v6 v7 v2 v3 v4 v5 v5 v6 v7. Doesn't seem right. Return 0. Let's compile it. So G++ 3.16.cpp. Get right. So we go 0, 10, 10, 1, 2, and 10, 10. Okay, great. So I'm correct here. Right, so another read a sequence of words from scene and store the values in a vector. After you've read all the words, process the vector and change each word to uppercase, printing the transformed elements. 8 words. Transformed element. 8 words to a line. Okay, read a sequence of words. 8 words to a line. 8 words to a line. I don't get this one. Okay, after you've read all the words, process the vector and change each word to uppercase. Okay, so read a sequence of words from scene and store the values in a vector. After you've read all the words, process the vectors and change each word to uppercase. Print the transformed elements. 8 words. Print the transformed elements. 8 words to a line. Okay, so 8 words should be in a line. Okay, so first of all, this is 3.17. So I'll create 3.17.cpp stream include vector and include string. Okay, so using cout cn and string and vector, and we have our main function. Okay, so let's define a vector of string. Let's strings. Then I'll create a string. Let's say value. We'll read it in, right? Strings dot push back value, right? So read the input. Then you go process by changing to uppercase. So hash includes cc type. Go for auto. s in strings, right? I get the, maybe I should get the reference, right? And then for auto and C and S, I want to say C equals to upper. I hope to upper is spelled like this and there is not a capital. It should be here somewhere. The strings, yeah, okay, so 2 upper, okay, I'm right. So 2 upper of C uppercase, then we go and print the result. So for auto S strings, I want to see out S and okay, so let's try this. G++ 3.17.cpp let's go Shane hash ace, and that's all. Okay. Shane hash ace. Okay, so I have a reference to the string. What if I fetch them by value? Will this be valid? I don't think it should be valid. We'll see. Okay, Shane is, yeah, okay. So need to add to both loops since we cannot work on read-only values. Alright, so there we go. I do get 8 words to a line. Okay, is the following program legal? I wake of 0. If not, how you might fix it? Okay, I'll go illegal as the vector is currently empty and you are subscripting the element that does not exist yet. Can use the pushback member to add 42 to the vector. Oh, sorry. Okay, list 3 ways to define a vector and give it 10. List 3 ways to define a vector and give it 10 elements, each with value 42. Indicate whether there is a preferred way to do so and why. Okay, so I would rather make 9.cpp. No, I don't need iostream. I'll just go with vector of ends and here vector. Okay, so first way is list initialization. Vector of int v1 list. Let's say here 42. Then vector int v2, we got 10 elements, each with value 42. We can list 3 ways to define a vector and give it, and vector int v3 is with copy initialization. Initialization from another vector. Initializes a vector of size 10, each with a default value of 42. Or vector int v3 v1. Okay. List initialization. Okay, indicate whether there is a preferred way to do so. Yes, the preferred way is okay. What is the spelling? Preferred. Okay, is with parentheses like v 10 comma 42. Okay. Read a set of integers into a vector. Print the sum of each pair of the adjacent element. Okay. Change the program so that it prints the sum of first and last elements, followed by the sum of second last, and so on. Okay, that is easy. So we'll go with clear supple 3.220.cpp, right? Yep. Okay. So using steady cout, steady cin, steady and l, and finally a steady vector. Okay. Alright, so what I want to do is read a set of integers into a vector, print the sum of adjacent elements. Okay, so I'll create a vector of int say v1, read some numbers, int temporary. It's better to initialize it with 0. Okay, well, scene temp and add to vector. So we have v1 dot push back temp print the adjacent elements, prints the sum of adjacent elements. Alright. Syntaxical type, we'll go with v1 dot size I equals 0 and I less than v1 dot size and I plus plus size minus 1. So I'll go with cout sum of I can format it, right? Let's use the hash include format. I can provide a format with sum of and is this. So I'll go I plus 1 and then I want sum to be v1 of I plus v1 of I plus 1 and then end line. Okay, so let's try this. Format is not number. Okay, G++ sorry dash std equals C++ 20 and then 3.1 3.20 dot CPP. Okay, so I'll go 10, right, 20, 30, 40 and 50. So then 30 up to 50. Okay. Right. Okay, of so v1 of I and v of I plus 1 is this. Okay, then when the sum of first and last elements and so on and so on. Okay, so since we are dividing the okay, yeah, right, so its condition, okay, dividing the space into half, hence we will only go up to size by 2. So for double type v1 dot size I equals 0 and I should be v1 dot size divided by 2 and I plus plus equals cout std Actually the same thing, but here v1, sorry, v of I, v of I. Okay, so we have v1 vi plus 1. Okay, plus 1, but I want vi, and then I want v1 dot size minus I minus 1 equals, let's copy this, copy, oh sorry, paste it here, and so size, okay, so let me see, 0 size, okay, so it should be less than whatever the number will be. Like for 5 it will be 2, will go 0, and this will be 0 minus 1, so the 1 should be here and the I should be here. Okay, so let's print error, so v1 of I, v1 of I, and v1 of this, v1 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 v1, right, v1, okay. Okay, so I'll go with 10, 20, 30, 40, 50. Let's try with an even number, right? Okay. So here we have 10 and 20, 20 and 30, 30, 40, 40, 50, 50, 60. Then 10 and 60, 20 and 30 and 40. Okay, what happens when I provide an odd number of so 20 and 40, and it does not, yeah, of course, because it won't do that. So great, I'm done here. So then we move on to introducing iterators. Although we can use subscripts to access subscripts to access the characters of a string or the elements in a vector, there is a more general mechanism known as iterators that we can use for the same purpose. Okay. As we'll see in part 2, in addition to vector, the library defines several other kinds of containers. All of the library containers have iterators, but only a few of them support the subscript operator. Technically speaking, a string is not a container type. Okay. Technically speaking, a string is not a container type, but string supports many of the container operations. As we've seen, string like vector has a subscript operator. Like vector, string also have, like vectors, strings also have iterators. Okay, I didn't know that. Okay, like pointers, iterators give us indirect access to an object. In the case of an iterator, that object is an element in the container or a character in a string. Okay. We can use an iterator to fetch an element, and iterators have operations to move from one element to another. As with pointers, an iterator may be valid or invalid. A valid iterator either denotes an element or denotes the position one past the last element in a container. All other iterator values are invalid. Okay. Using iterators. Unlike pointers, we do not use the address of operator to obtain an iterator. Instead, types that have iterators have members that return iterators. In particular, these types have members named begin and end. The begin member returns an iterator that denotes the first element or first character, if there is one. Okay. The iterator returned by end is an iterator positioned one past the end of the container associated or string. Okay. This iterator denotes a non-existent element of the end of the container. It is used as a marker indicating that we have processed all the elements. The iterator returned by the end is often referred to as of the end iterator or abbreviated as the end iterator. If the container is empty, begin returns the same iterator as the one returned by end. Okay. If the container is empty, the return equal if they are both of the end iterators. Okay. In general, we do not know or care about the precise type that an iterator has. In this example, we used auto to define B and E, where B and E. Okay. As a result, these variables have whatever type is returned by begin and end members respectively. Okay. Iterators on page 108. Iterator operations. Iterators support only a few operations which are listed in table 3.6. We can compare two valid iterators. Iterators are equal if they denote the same element or if they are both of the end iterators for the same container. Okay, otherwise they are unequal. Okay. As with pointers, we can dereference an iterator to obtain the element denoted by an iterator. Also, like pointers, we may dereference only a valid iterator that denotes an element. Dereferencing an has undefined behavior. Okay. As an example, we'll rewrite the program 316 that capitalized the first character of the string using an iterator instead of subscript. Okay. Let's begin. So value s begin is not end. Make sure s is not empty. It denotes the first character in the string. Make the character uppercase. Okay. As in our original program, we first check s is an empty. In this case, we do so by comparing the iterators returned by beginning and end. Okay. Those iterators are equal if the string is empty. If they are unequal, there is at least one character in s. Okay. And inside the if body, we obtain an iterator to the first character by assigning the iterator returned by begin to it. Okay. We dereference that iterator to pass that character to upper. Right. We also dereference it on the left hand side of the assignment in order to assign the character returned from to upper to the first character in s as in our original program. Okay. So dereference returns the reference to the element denoted by it dereferences iter and fetches the member named mem from the underlying element equivalent to this. Okay. Then increments iterator to refer to next element, decrements iterator to refer to the previous element in the container, compares to iterator equality to the inequality. If they denote the same element or if they are of the end, they are same. Moving iterators from one element to another. Okay. Iterators use the increment operator to move from one element to the next. Incrementing an iterator is a logically similar operations to incrementing an integer. In the case of integers, the effect is to add 1 to the integer's value. In the case of iterators, the effect is to advance the iterator position by 1. Okay. Because the iterators returned from end does not denote an element, it may not be incremented or dereferenced. Right. Okay. Using the increment operator, we can rewrite our program that changed the case of the first word of in a string to use iterators instead. Okay. So process the characters in S until we reach the end of the character or we hit a white space. So we go auto S and IT plus iterator. Okay. The iterator is not end or iterator is a white space. So we begin, iterator is not end, iterator. Capitalize the current character. This loop, like the one in, iterates through the characters in S, stopping when we encounter a white space. However, this loop accesses these characters using an iterator, not a subscript. The loop starts by initializing IT from sBegin, meaning that IT denotes the first character, if any, in S. The condition checks whether IT has reached the end of the S. If not, the condition next dereferences it and passes it to the current character if space to see whether we're done. Right. At the end of each iteration, we execute plus IT to advance the iterator to the next character. Okay. The body of the loop is the same as the last statement, previous F. We dereference it to pass the current character. Right. Assign the resulting uppercase letter packed into character denoted by it. Key concepts: generic program. Programmers coming to C++ from C or Java might be surprised that we used rather than less than in our for loops, such as the one above, and the C++ programmers use as a matter of habit. They do so for the same reason that they use iterators rather than subscript. This coding style applies equally well to various kinds of containers provided by library. As we have seen, only a few library types, vector string being among them, have the subscript operator. Similarly, all of the library containers have iterator. Okay. Similarly, all of the library container have iterators that define equal to none. Most of these iterators do not have less than operator. By routinely using iterators and not equal to, we don't have to worry about the precise type of the container we're processing. Yes, that is right. Okay. Then we have a iterator type. Just as we do not know the precise, I think I should leave it for next time. Okay, there we go. So, ta-da, bye bye.